Number 2. We continue to be a day behind, which means that we have scheduled the test that was originally scheduled for tomorrow. We moved it back to Wednesday. Over the weekend, I was walking my dog and thinking about things. I do. Chihuahua. I'm just kidding, I don't have a Chihuahua. Would that fit with me? No, I didn't.
I feel like you fit with your daughters.
Yeah. And I did not like the thought of having the test on Wednesday. So, here is the up-to-the-moment plan. Some of it you will like, some of it you may not. I'm not sure, but here's the thought. Please listen so that everybody knows, and I don't have to say this 7 times. Okay? The thought is, let's move the test to Thursday, but we cannot fall another day behind. In fact, it's going to be hard enough to pick up 1 day. We could never pick up 2. So what we'll do instead is tomorrow we will start on chapter 8. We will do 8.1a in class tomorrow. That will not be on the test on Thursday. Okay? But so that we don't lose a day, we will do that tomorrow. Wednesday, we will do homework check and review. And then Thursday, we will test on the back end of chapter 7. Does that sound okay? Questions, concerns, problems? Yes, ma'am.
They say we have to go to the auditorium for juniors on Wednesday, but I kind of want to come to ACLA. Does it matter?
I think it said if you are not requested by a teacher.
Okay.
So I'm not going to request you, so no, I'm just kidding. Just kidding. But I believe that's what it said. I'm not 1,000% sure, but I am pretty sure that's what I saw.
Okay.
Any other questions or concerns about any of that? Is that all reasonable? Does that change more positive or more negative for you guys? Positive? Okay. So we're good? Everybody's good with where we are and what's going on? Questions? Homework, go. Okay. I'm guessing that there are going to be questions on 5, 21, and 49.
Yeah, all the cotangents.
Not just cotangent ones, but cotangents, inverse cotangents of a negative number. And that is because that's something we didn't really talk about on Thursday. So let's talk about it now. Okay? So let's get to the hardest one. I mean, it's not, there's really no difference in them, but let's jump to 49. And then we will figure it all out as we're going through it. Okay? So number 49 says the inverse cotangent of negative 0.5774. Inverse cotangent of negative 0.5774. So, your first step was you changed it to tangent. So you wrote inverse tangent of 1 over negative 0.5774. You made sure that you put your calculator in radians because the answer was asked for in radians, correct? And you punched that into your calculator and you got negative 1.05.
Yes.
And you said, my answer is negative 1.05, I got it, and you checked the back of the book and the book said something totally different. Am I way off base? Okay, here is why. On Thursday, we talked about range for inverse sine, inverse cosine, inverse tangent. Okay? And we said that the range for inverse sine was between negative pi over 2 and pi over 2. In other words, in quadrants 4 and 1. Yes? And for cosine, inverse cosine, the range was from 0 to pi. In other words, quadrants 1 and 2. And for tangent, inverse tangent, we said the range was from negative pi over 2 to pi over 2, so quadrants 4 and 1. And that's where we stopped. Okay? The assumption, logical assumption, makes sense, is that the reciprocal functions would have exactly the same range as the original functions. And for the most part, that is correct. The range for cosecant, inverse cosecant, is exactly the same as the range for inverse sine. The range for inverse secant is exactly the same as the range for inverse cosine. But tangent and cotangent, for some reason, which I'll explain in a second, it's not the same. So when we do inverse tangent on our calculator, they're giving us a fourth quadrant angle. This, even though it's in radians and we don't understand radians quite as well as we understand degrees, but if negative 1.05, you know it's a negative angle, so you know it's going down, and it's not going down that far, so it's in the fourth quadrant. So they gave us a fourth quadrant angle. However, the range for inverse cotangent is from 0 to pi, in other words, in quadrants 1 and 2. Okay? So the only thing that we have to do is we have to take this angle and put it into quadrant 2. Well, except that this is in radians. So now, what is the reference angle here, by the way? Remember, this is in the fourth quadrant, right? So let's say that we had negative 60 degrees. Let's say that was our angle. It's not. It's negative 1.05. But just to put it in a degree thought, if our angle was negative 60 degrees, what's our reference angle? 60 degrees, right? Because negative 60 degrees is like that, which makes that 60 degrees, which makes the reference angle 60 degrees. Okay? Well, the same exact thing holds true when it's in radians. Okay? We're coming down 60 degrees, so the reference angle is 60. When we're in radians, we're coming down 1.05, so the reference angle is 1.05. So our reference angle is 1.05. We okay with that? By the way, that's going to happen every time when we're doing inverse sine, inverse cosecant, inverse tangent, because they're giving us a fourth quadrant angle. So anytime they're giving us an angle in the fourth quadrant and it's negative, then the positive version is just the reference angle.
How did you get negative 1.05?
I just plugged it into my
Oh,
calculator.
okay.
So the reference angle is 1.05. Are we okay there? All right, so now I know the reference angle. Where do I have to put that? According to this, we got to put it into quadrant 2. So how do we put it into quadrant 2? Yeah, so we're coming here, remember, and that's pi. And so, well, I don't know where 1.05 is. Actually, it's somewhere around 1 radian. But so it needs to be like that. And so that's going to be pi minus 1.05. Last I checked, pi is approximately 3.14 minus 1.05 gives us 2.09, which I have to believe was the answer that was in the back of the book. Does that make any sense? So everything you did was fine. And it was just the fact that we hadn't talked about the range for the reciprocal functions yet. And cosecant is fine. Secant is fine. It's just when we get cotangent that we get that messed up thing. Okay? And so you see how you would do it for, what was it? 5 and 21?
Yeah.
Okay. Check those out. Let me know if there are issues there. But all we're doing is changing quadrants. We're taking the answer we got from our calculator or from the chart, and we're just putting it in the second quadrant rather than the fourth quadrant. Yes, ma'am.
For number 21, it said that the answer was 210. Isn't that in the third quadrant?
Said it was what?
Oh, okay. I wrote the 1 and the 2 backward.
Okay.
Never mind. Okay.
That makes a lot more sense to me.
Yeah.
Makes more sense to you, too. That's a win-win right there. It makes more sense to both of us. We're doing good. Others? Good?
Infinity.
My guess is, for those that did the homework, which it sounds like a lot of you guys did, which is a good thing, obviously, but my guess is that for the people that did the homework, with the exception of the cotangent stuff, it probably wasn't all that bad. Is that a fair statement? Good. That's the way it's supposed to be. So, let's make it harder. Just kidding, it's actually not going to be that hard, that much harder. But I just wanted to hear Jake's reaction, that's all.
Okay. So 7.7?
7.7.
If I remember correctly, we did a problem at the very end of class on Thursday, which I said is kind of a general idea of what we're getting into today. Is that correct? Yeah. Perfect. And we did that problem. Second hour tried to tell me I wrote it on the board but didn't do it. And then I did one like it today, and they're like, oh, no, we actually did do that.
There was one in the homework.
Yeah, but the one in the homework said something like this. It said, I believe it was the inverse sine of the sine of 5 pi over 12, I think. And your answer was
5 pi over 12.
5 pi over 12. And we like that. Exactly. We like that. And so now, what happens if we say the cosine of the inverse cosine, no, let's do it the other way. The inverse cosine of cosine of 7 pi over 6.
7 pi over 6.
And your answer is?
7 pi over 6.
Not 7 pi over 6.
Why does that hurt?
It's never
It's never
that.
that
It was on
easy.
the first one. It was on your homework problem. Can anybody tell me why the answer is not 7 pi over 6?
Is this cosine?
It's the big Q word,
Quadrant.
quadrant. Because the answer to an inverse cosine problem
It's in quadrant 2.
has to be in either
Quadrant 2, 1, and 2.
quadrant 1 or quadrant 2. 7 pi over 6 is in,
Quadrant 4.
some people got it right,
Quadrant 4.
quadrant 3. What is the angle of 7 pi over 6?
210.
No, but I mean the actual angle.
210.
210, right? The 6 means 30 degrees and 7/30s. 210 is in quadrant 3. And the answer to an inverse cosine problem cannot be in quadrant 3. So we need to put it into the correct quadrant. The question becomes, is the correct quadrant quadrant 1 or quadrant 2? How do we decide that?
Math.
Math? Good idea. The cosine of 7 pi over 6, I don't care what it is. I mean, we can figure out what it is, but I don't care what it is. All I care about is whether it is positive or negative. So will the cosine of 7 pi over 6 be positive or negative?
Positive.
Think it through, and then give me the correct
Oh.
answer.
Like negative. Wait, no.
Talk about it.
Because it's in quadrant 3.
Talk about it.
So it's negative.
Right.
Don't talk with me about it. I'm not going to listen.
Quadrant 2. So we're taking from negative and making it positive.
I think it's not.
Wait, oh.
Like, I don't know.
Because we're doing it, because like you said, it's in quadrant 3, so it's we have to put it in quadrant 2 and then try it.
Did we come up with an answer? Is it positive or negative? Because
It's in quadrant 3.
it's in quadrant 3. Remember, the only thing that dictates positive or negative is quadrant. Okay, so the cosine of 7 pi over 6 is negative, which means that the inverse cosine of that must be in
Positive.
quadrant 2. Does that make sense? We're doing an inverse cosine problem. So inverse cosine is either in quadrant 1 or quadrant 2. When we're finding the inverse cosine of a positive number,
Nice things.
we'll be in quadrant 1. When we're finding the inverse cosine of a negative number, we'll be in quadrant 2. So that's why we were asking the question, cosine of 7 pi over 6 positive or negative? Since it's negative, then the inverse cosine of that is going to be in quadrant, which one? 2, I just said. If we're getting the inverse cosine of a positive number, if that's positive,
No.
cosine of 7 pi over 6. If that was positive, then our answer would be in quadrant 1. If cosine of 7 pi over 6 is negative, then our answer would be in quadrant 2. So in this case, since it is negative, it's going to be in quadrant 2. So all we have to do is figure out a way to put 7 pi over 6 into quadrant 2. So what do we need first? Reference angle. What is the reference angle?
30.
Pi over 6. Reference angle is pi over 6. This is the one, well, I'm sure there are a couple, but one of the nice things about working in radians is the reference angles are really easy to figure out. If it's reduced, like I'm not saying 8 pi over 6, because then you could reduce that. But if it's reduced, then the reference angle for 7 pi over 6 is going to be pi over 6. The reference angle for 5 pi over 4 is going to be pi over 4. The reference angle for 4 pi over 3 is going to be pi over 3. So that's the nice thing about radians, is the reference angles are really easy to come up with. Our reference angle is pi over 6. Where are we trying to put that? Quadrant 2. Pi over 6 in quadrant 2.
Pi minus pi.
5 pi over 6 is correct. Because remember, we're subtracting pi over 6 from pi. And pi is 6 pi over 6, 6 pi over 6, minus pi over 6, which is 5 pi over 6. Okie dokie. Questions there? All right. Let's do the next one. Let's do tangent of the inverse cosine of 2/5.
That's legal.
Tangent of the inverse cosine of 2/5. Triangle.
What? It's like when you first said like when you write the
Oh,
because you said it too early.
You want everybody to give a second or two?
Yeah, just a,
So what I'll do is I'll delay my asking of the question.
okay, thank you. It just,
Good idea on my part. Yep.
thank you, sorry.
No, okay. I want you to have time to think. But what hit? Triangle. Why? Because
Because there's two
it's not on the chart. Simple as that. So we draw a triangle. It's a terrible triangle, but it's good enough. So tell me what to write.
Hypotenuse is 5.
Hypotenuse is 5.
Adjacent is 2.
Adjacent is 2. What goes here? Alpha, X, whatever. Makes no difference. So what does this say inside the parentheses? Yeah, I know, but give me better words. What angle? Find the angle
Gives us the cosine of 2.
that is a cosine of 2/5. There it is. Found it. It was hiding, but we found it. Okay, now what does it ask us to do?
The tangent of that angle.
Find the tangent of that angle. So, okay, let's find the tangent of that angle. What do we need?
Opposite.
We need that, which is? Okay. So, go slow.
You're good.
5 squared
Minus 2.
minus 2 squared. Square root of 21. So, what are we going to do now?
Find the tangent of alpha.
Don't need a reference angle, because we found the angle, right? So once we find this angle, whose name is alpha, we now want to find the tangent of alpha. What is the tangent of alpha?
Square root of 21 over 2.
Square root of 21 over 2. You'll be done. Questions on this? We okay?
Wait, over 6.
All right. Let's.
Okay, alright. Really gotta stop smudging this. Okay.
The inverse cotangent of the cotangent of 5 pi over 4. Which clearly the answer is
5 pi over 4.
5 pi over 4.
But it's not.
Not.
Okay, how do we know?
Because now.
When it's not.
Oh, it's in quadrant.
This is an inverse cotangent problem. Okay? What quadrants can our answer be in? Okay with that? What quadrant is 5 pi over 4 in? Therefore, the answer to an inverse cotangent problem cannot be in the third quadrant. By rule, by law. You get like thrown in jail and stuff like that. So, we're in the wrong quadrant. So we have to figure out two things here. Number one, what is the correct quadrant? Why do you say quadrant 1? 50-50 guess?
Yeah.
Okay?
Wait, isn't it quadrant?
Not 1 or 4, 1 or 2. Say it again?
Isn't it quadrant 2 because that's negative because it's in the. Oh, no, it's positive.
That was awesome. I love hearing the way that went through your head. Because pretty much, okay, so this is in, so this angle is in third quadrant, and the cotangent of that angle, therefore, is positive. So therefore, we're getting the inverse cotangent of a positive number, which therefore puts our answer into quadrant 1. There's a lot of talking, thinking in these problems, and not a lot of writing, you know? But it's the understanding of everything that's the big thing. Go ahead. So, since it's going to be in the first quadrant, we then need the reference angle, which is pi over 4. And pi over 4 in the first quadrant, you said, is pi over 4. And there's our answer.
See, I like that.
A lot of thinking, like I said. A lot of thinking.
Nice restroom.
All right. Ready? Wow. The cosine
Of the cotangent.
of the inverse tangent
That was close enough.
of 12/5. Ooh, that wasn't like the end. He said of 12/5 plus the inverse sine of 3/5. So, My question to you right now is, do you want the challenge of trying to work on this for a couple of minutes by yourselves? Or do you want me to just jump right in? Challenge?
Jump on it.
You want the challenge?
Jump on it.
Go for the challenge.
Don't know what to do. I was gonna say.
I will tell you this. You do want to talk about this one a lot as you're going through it. Once we
But
get
I don't know
to
what
it.
to use.
Oh, and by the way, calculators are not
So let's do the two.
necessary or even allowed on this problem.
That hurts my soul.
No calculators.
I mean, what are the formulas gonna be? Not much, right?
What's what?
Wait, no, just do it like this one.
Wait, can we, draw a triangle or something?
Yeah, just draw two triangles.
One tangent, one cosine.
Is this pause? I'm gonna pause.
Inverse tangent of 12 fifths, right? Tell me about it. Draw a triangle. So we draw the triangle. 12 there,
Yeah.
5 there.
Yeah. 13.
Okay, I don't care. What are we asking for right here?
What angle?
Well, what?
Angle.
What angle? This says what angle has a no, not what angle gives us, but what angle has a tangent of 12 fifths? Alpha, where's alpha?
I paused it.
Alpha's here? Okay,
Is it playing now?
so have we found the angle? Yes, we have. It's right there. Okay. Then what's next? Draw another triangle.
Okay, so what are you feeling?
Okay. What do I write? 3. Where do I write 3?
Opposite.
Opposite is 3.
Hypotenuse is 5.
Hypotenuse is 5.
Alpha.
Alpha?
Beta.
Why not alpha?
Because you already have an
It's a
alpha.
different angle. It's a different triangle. It's a different angle, so we'll call it beta.
Oh, it was a formula.
So, an inverse tangent of 12 fifths is what? It is alpha. The inverse tangent of 12 fifths is alpha. What is the inverse sine of 3 fifths? That is beta. So what are we being asked?
Cosine of alpha plus beta.
What is the cosine of alpha plus beta? Which means
Formula.
we need the formula. And if you get to the point where you recognize that this is the cosine of alpha plus beta, in my opinion, the rest of the problem is easy. Cosine of alpha plus beta is equal to
Cosine of alpha.
cosine of alpha,
Cosine of beta.
cosine of beta,
Plus sine of alpha.
What?
Plus sine of alpha.
not plus,
Oh, minus sine
minus
of
sine of
alpha.
alpha,
Sine of beta.
sine of beta. So now what? What do we want to know now? The cosine of alpha. Do we know the cosine of alpha?
Yes.
We will as soon as we, this is
13.
13. This is 4. Now we good to go?
Yes.
Go. Cosine of alpha.
5 over
5 over 13 times cosine of beta. 4 over 5 minus sine of alpha. 12 over 13 times sine of beta. 3 over 5. Resist the urge to cancel. Could you cancel here?
For the first 5.
What could you cancel? The 5s. You can cancel the 5s here. Don't. You'll see why in a second. 5 13s times 4 fifths.
20 over 66.
20 over 65 minus 12 13s times 3 fifths. 36 over 65. Do you now see why I suggested you did not cancel? So now we have, nice common denominator. 20 over 65 minus 36 over 65 gives us,
negative 16.
that is our answer.
But you said that you're not gonna put the formulas on the, actually, no.
I haven't said anything yet. I'll fill everything in tomorrow. I was working on the exam stuff today, and I should probably work on the test stuff before I work on the exam stuff. But the exam stuff I gotta ship out to get it copied, and so that's why I was working on that. But that's a good point. Now, for those of you that try to do the cosine of alpha plus the cosine of beta, did people try to do that?
Yeah.
What did you get when you did that?
77 over 65.
76 over 65?
77.
Which at that, huh?
77.
77?
Yeah.
Which when you got that answer, if you're really thinking, you know that that's not correct because it's higher than 1. And this is saying the cosine of anything. And so the cosine of anything can never be greater than 1. So hopefully, you know, if you really are thinking the trig stuff through, once you get here, you go, ooh, that ain't right. Okay, so questions on this? Was it fair to say that once you realized that it was the formula and you wrote that down, it's pretty easy from there? Yeah. But the tough part is recognizing what it is. And so sometimes it's in your best interest to go inverse tangent of 12/5, let's just call that alpha. Inverse sine of 3/5, let's call that beta. Ooh. And as soon as people started seeing cosine of alpha plus beta, I started to hear people go, ooh, formula. And that was perfect. Questions? Okay, we have 2 options from here. Option number 1 is I could do another problem. Option number 2 is we can call it a day and I can put the work up on the board and you can get to work on your homework. You got about 20 minutes. Most people in the other classes, we went straight to homework. I'm 100% fine with that. I think that's probably the best idea. But if everybody said, no, I want another problem, then I'd adjust. But
Homework too.
Yeah.
you guys can do
We
another
labeled
problem.
both of these out, these the same
I'm
thing.
not going to know.
This one, we labeled
Just
both
kidding.
of these angles the
I'm
same
here
thing.
for everything.
This would be
All right,
alpha.
so we're going to put stuff up on the board. We're
So
going to
it
get rocking
would
on
be
homework.
cosine of alpha plus cosine of beta, and then that's
And we're
the
good to go.
formula.
Questions? I'm going to use my remote.
I'll explain.